We started the work by conducting an expert analysis, which revealed that all the building's moisture protection measures from the very beginning failed, and therefore it was necessary to simply apply a completely different method and, in fact, create a true waterproofing in that building. For many years, the building was under the influence of intense and, importantly, recurring groundwater impact. This process led to the systematic penetration of moisture into the structure of the walls, more so in the ground-level areas and basements. The result was not only periodic flooding of the underground rooms reaching up to a height of 60 centimeters, so you can imagine how serious the damage was. Also prolonged dampness of building partitions and consequently the degradation of their mechanical and insulating properties, as well as the activation of destructive physico-chemical processes. Here we mean mold growth. The main cause of the discussed problems was the originally faulty installation of moisture insulation during the construction of the building. Particularly unfavorable conditions prevailed around the internal stairs, where improperly constructed formwork created spaces for direct water inflow. The actual level of groundwater in this area is not known, however, based on technical observations and analysis of the height of the originally applied bituminous insulation. It was done up to a height of 150-160 centimeters in some places from the floor. It can be maintained that the groundwater level remains relatively high. This indicates the possibility of vertical water impact on the entire height of the wall, which exacerbates the problem of moisture migration and the difficulty in stopping it in a pinpoint or linear manner. And interestingly, in subsequent years, ad hoc attempts were made to solve the moisture problem using readily available bituminous materials. In many places, proper substrate preparation was not ensured, leveling, dust removal, and drying were neglected, and moisture parameters exceeded the permissible technological standards for waterproofing works. As a result, the insulation showed a lack of continuity, incomplete adhesion to the substrate, and variable thickness. Particularly critical were the areas where walls connected with foundations, which were completely overlooked during the initial protection stage. The applied waterproofing measures lacked the ability to permanently bond with damp concrete and masonry, leading to their degradation already during the operational phase. The final stage of these repair attempts was the application of a dedicated waterproof concrete screed of class C25, C30 with a thickness of 16-20 centimeters. Although the material itself is characterized by good tightness, it was not properly bonded with the wall structure. This screed only served to protect the floor, not covering the critical junctions of the walls with the foundation. Moreover, old layers of bituminous insulation and plaster were left under its surface, which still allowed moisture retention and its further migration into the interior of the building.